Hey guys, this is Mr. Bennett. I'm sorry I couldn't be with you today, but we're going to start our notes anyhow for Unit 5. You'll do fine. I'm here with you in spirit, and we're going to learn about the groups and periods of the periodic table, as well as how to calculate the number of valence electrons. The first thing we're going to learn about is how to identify the groups and periods of the periodic table. So here we have a picture of our periodic table, the periodic table that we use in class. And it turns out that the groups and periods are things that we've talked about already, but we've never really given it the name of a group or period. So for example, our groups, we're going to look at our groups as being the columns of the periodic table. So here we would call this group 1. And if you actually sneak in there real close and look at your periodic table, what you'll see is that above this column of the periodic table, it's actually labeled group 1, so there's a 1 on top, and then below that there's a 1A. We'll talk more about that 1A in the future. Essentially anything with an A after it is called a representative element. But for our purposes, we would call this the group 1 elements. And then that means that the next column on the periodic table, this is group 2. Okay, now here's where it gets a little tricky though. Okay, so if you look down here, this is group 3, and so it continues through that middle section of the periodic table, group 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we get all the way across to the P block, and we're up to group 13. Okay, so that's group 13. Okay. The tricky part. Don't get confused by those A's. In other words, this is group 13, but it's also known as 3A. We'll talk about how that 3A can be useful to us later, but keep in mind that it's the number on top that actually tells you the group number. So that's groups of the periodic table. And what you'll see is if you go all the way across, the final column is group 18. So there are 18 groups on the periodic table. Okay, so that's groups. Now for periods. Well, so far we've been looking at columns, right? Groups are the columns. Okay, now let's look at periods. So if you're jumping ahead right now and you've already figured it out, periods are the rows of the periodic table. And up until now, we've often referred to them as the energy levels, although we knew it wasn't entirely true because when we get to that D block, remember, those rows are technically a row below where they're supposed to be. But anyhow, back to periods. So periods are the rows of the periodic table. So if we look at this, for instance, this top section where we find helium and hydrogen is period 1. Okay, I'm going to put PER for period 1. Here is period 2. Here is period 3. And in fact, it's already labeled for you. Period 4, period 5, period 6, period 7. So the periods are simply just the rows of the periodic table, right? And as we go down the periods, we're getting atoms with more and more energy levels. Okay, so those are groups and periods of the periodic table. That's our first topic for this video. The next topic is going to be how to calculate the valence electrons, and we're actually going to shift into a video that I made last year. So when this background changes and things look a little different, that's because we're looking at a video clip from last year that I made that explains the valence electrons. So here we go.
Periodic table, we talked about the idea that it's organized around the characteristics of elements, meaning that if an element has a similar chemical property to other elements, then they'll be in the same group, family, or column. Okay, we didn't explain why though. The why goes back to an idea from last unit, something we call valence electron configuration. Let's take for example sodium. Sodium has 11 electrons. So if we were to write its electron configuration, it would be 1s2, 2s2, 2p6, 3s1. Now valence refers to the outer energy level. So if we were to look at this, its innermost energy level is the first energy level, that's the 1, its second energy level is here, and its outer energy level is the third energy level. It has 1 electron currently in the third energy level within that s sublevel. So we would say that it has 1 valence electron in the s of the third energy level. Now, the reason why valence are important is because they determine chemical reactivity. So if you have similar valence electron configurations, that means you have similar chemical properties or chemical reactivity. So going back to sodium here, sodium we just said its valence configuration is 3s1. If we were to look at lithium, lithium's valence would be 2s1. Hydrogen would be 1s1. Potassium would be 4s1. Rubidium would be 5s1, and so on. Go all the way down. This would be 6s1, 7s1. So they all have 1 electron in their s sublevel. Turns out that these chemicals react similarly when it comes to chemical reactions. And if we were going to the second row or second column, this guy here would be beryllium, would be 2s2, magnesium would be 3s2, and we could go down the list, 4s2, 5s2, 6s2, and they all behave in a similar way chemically because they all are ns2. Okay, same thing for group 13 or 3a. It's going to look like this. All the elements in group 3a or 13 behave similarly because they have ns2 and p1. So we can simplify this. I know that sublevels and energy levels gets a little confusing, especially if we're talking about them in multiple energy levels. So let's make it simpler. If we look at group 1, okay, so all the way down, this whole section here, okay, I know that's not pretty, but anyhow, so if we look at group 1 or group 1a, again, they have 1 electron in the s, so we would say that it's 1 electron in the s sublevel, 1 valence electron. Group 2 has 2 electrons in the s sublevel, which means it has 2 valence electrons. Okay, we go on to group 13 or 3a, 2 here, 1 here, that means 3 valence electrons. Group 14 or 4a, we have 2 electrons here and 2 electrons here, so that's 4 valence electrons. Now if you haven't picked up on it yet, check this out. Group 1 and group 2 coincides with their valence electrons. But then we jump to group 13. Okay, we don't have 13 valence electrons, but if we look at the number next to the A, that does coincide, right? 1a was 1 valence, 2a was 2 valence, 3a was 3 valence, 4a was 4 valence, so that means 5a is 5 valence electrons, 6a is 6 valence electrons, 7a is 7 valence electrons, and 8a is 8 valence electrons. Okay, we can double check this here. Notice s plus p gives us 5. S plus p gives us 6. S plus p, or 2 plus 5, gives us 7. So when we're looking at the valence electron number, there's 2 ways you can do it. You look at the number next to the A, or you take S plus P. Either way will give you the valence electrons.
All right, so that was our lesson on the columns, the groups, as well as the rows that we call periods, and we learned how to calculate valence electrons. For the remainder of class, you need to finish your review 5.1, so answer the questions that go along with these notes. Also, make sure that you get it stamped. The sub will only stamp your work if it's complete. Remember, tomorrow we will finish up our projects. If you plan on printing out a picture that you're going to glue or put into your project, then you need to do that tonight and make sure that you bring it with you tomorrow. Since tomorrow, I will be back and we can review 5.1 and answer any questions that you had. All right, have a great day.